So hello everyone, welcome back to my YouTube channel. In today's video, we are going to solve problem number 3756. That is the second part of yesterday's problem. So everything is same. Just instead of finding just one array, in the previous video we were finding the complete, like we were finding the new number from 0 to 7 and the summation of 0 to 7. Then we were simply multiplying both the numbers and we were returning it. But in this problem, the only difference between yesterday's problem and today's problem is that we don't have to find only one such case. There will be around 10 raised to the power 5 numbers of queries, and we have to do the same. So if we are going to do this problem by using a naive approach, then what would be happen? Because for every iteration, okay, so suppose if I am going to solve the problem using this way. So this problem was being solved in big of n times of complexity. And if there are m number of queries, so what would happen? The time complexity will be raised to m into q. And in the worst situation, our queries can be 10 raised to the power 5, and our number of string length can also be 10 raised to the power 5. So our total time complexity will be, in the worst case scenario, it will be big of n square, that is 10 raised to the power 10, which is much greater than 10 raised to the power 8, and eventually we will get a time limit exceeded. So to solve this problem, we can solve this problem because it's a case of the number of queries. So one thing we can think of is solving this problem by using a segment tree. But implementing a segment tree is itself a very difficult task. So what we can do, instead of using a segment tree, we can use as we know that our prefix, the concept of prefix array. So by the help of this prefix array, we are going to solve this problem. First of all, let us understand what the problem says. Suppose if we are given if we are given the string 10203004 and our queries. On the first query, I am getting 0 to 7. So for 0 to 7, my string will be 10203004. But we know that our new number should be, there should not contain any 0 in our string. So our new number will be 1234 only. And the summation of all these numbers is 10. So our product is 1234 and 0. In the second case, if I am given a query of 1 to 3, our string will be from 1 to 3, the number is 0 to 0. So our number, excluding the zeros part, our number will be only 2, and our summation of all this number will is going to be 2, and our output will be 4. And in the third case, it is written that our if the query is from 4 to 6, our actual string is 300, but our new number, in which we are ignoring this 0 part, our new number will be 3, and the summation of this number is going to be 3 only. So what we can say that the solution of this part is 6. So what we have to return? We have to return an array of having these numbers like 1, 2, 3, 4, 0, 4, and 6. So as you can see, we have to return this part. But if we are going to solve this in our previous approach, finding this number and summation will only take off big of n. And the number of queries can also be big of n. So the total time complexity of the solution will be, in the worst case will be, it will be big of n square, and we will get a time limit exceeded. So we cannot solve this problem by using our traditional approach. So what we are going to do, we are going to use the approach of that is called as the prefix sum. Okay, so what are the requirement for this problem? The very first requirement is of creating a new number. We have to create a new number. Number two, we have to require the summation. So this part is very easy because it is our traditional part. Like we have used a prefix sum to calculate, because this is a very easy approach of calculating the summation. So if we are given some ranges and we want to calculate the sum of any numbers, okay. So how it is going to work? First of all, I have to create a prefix sum. How it is going to help us? Because whenever there is some query from L to R, I can find the summation in big of 1. So what I'm going to do, I'm just I'm just the time complexity that I use initially to find the summation and the new number is big of n. I have to decrease the big of n into big of 1 only. So this is my main approach. So to do this, I am going to use a prefix array. So because prefix array can give me a solution, give me any query in a big of 1 time complexity, and there can be a number of n queries. So my time complexity will be big of n, and it will be accepted on the LeetCode. So first of all, I have to create a prefix sum. So the prefix summation of this number will be, for 0 it is 1, for 1 it is 1, for index number 2 it will be 1 plus 2, that is 3, for 3 it is already 0, so 3 plus 0 is going to be 3, and for number 4, uh, till here we have 3, and 3 plus 3 will be 6, so we have 6 here, and for it is 0, it is 0, so there won't be any changes, so it will be 6 here, it will be 6 here, and in this case I have my 4, so the last number is going to be our 10. So after creating a prefix sum, I have to create a prefix number, prefix of a desired number. So what does it means? Prefix of a desired number means that I have to ignore all the zeros in between, or I have to ignore all the zeros, whether it is in between or in the front, because I have to create a prefix of non-zero. So I have to create a prefix of non-zero. For first one, it is 1. For the first index, it is 1 only. For the second index, it will be 1 plus 2, that is 12, not 102, because obviously I have to ignore this 0. So it should be 12 here. And for third index, it is 12. For fourth index, as you can see that our actual number is 12003, but I have to ignore these zeros. So my number will be 123. So I'm going to store 123, and for as same as for 5 and 6 it would be same, and for 7 my number is 1234. So as you can see this, by creating a prefix of non-zeros and prefix of sum, I can get my original number, I can get my desired number and my summation in big of 1 of time complexity. So how we are going to perform the query, how we are going to address the query? Suppose if this, okay, so this is my number, and this is my summation. Why I'm using here count digit, I'm going to tell you in a while. First of all, let us check for the query L comma R. That is, if the query is 0 to 7, or for 0 to 7, our desired number is, for 0 to 7, our desired number is 1, 2, 3, and 4. And our summation required is 10. So our output is 12340. So we are getting our desired output. It is a case when both left and right are the extreme cases. It means that when the left is 0 and the right is 7, and we are actually covering the complete array. So in that case only I'm getting the answer 12340. What happened if my query starts in between these arrays? Like if I have to calculate from 1 to 3. Suppose if I have to if I want this much only. So if I'm going to use this only, like if it is 1, 2, and 3, I'm going to use this one. So for using 1 comma 3 index, our my num- our the actual number is 0 to 0, but my desired number will be 2, and my summation number will be 2, and the output should be 4. Okay, so this is my desired output now, and I hope that you know how to perform a query, because to know the query you have to just use s of r minus s of L minus 1. So it is the condition of finding a number, because if you are using a S of R, you are already covering from 0 to 6. And if you use from 0 to suppose 5, so you have to use this much on, you have to subtract this much, so that you can get the desired your output. So this is how we are going to perform the query. So for finding the summation, the number could for 7s of 3, like summation of 3. For summation of 3, I have stored 3 here, and for s of 0, I have stored 1 here. So my required sum is 2. So for the summation part, we are getting the correct answer, that is 2. Let us see about the number part. For the number of nums of 3 is storing 12, but nums of 0 is storing 1. So if I'm going to subtract 12 minus 1, what I'm going to go, what I'm going to get, I'm getting 11, which is not our required output. I should have, instead of 12, I should have 10. So how can I know that how many numbers should be there? So I have to calculate the number of digits. Okay, suppose if so this that's why I'm using a count digit, because if I have a 12 but I require a number 2, so I have to subtract 10 from here. So this is how we are going to store. I should have something power of something. So this count digit is going to help us. How? Okay, so let me tell you, this is the way we are going to solve this. Like, if P of 3 and P of 0. First of all, I hope you know how it is being calculated, because since for the number there is number 1, so it should be 1. Here it is 1, here should be 1. Here it is 1 and 2, so the count of digit is 2, so I am going to store 2 here. Here it is 12, so I am going to store 2. 1 to 3 is there, 3 should be there. 1 to 3 is there, 3 should be there. Same like this. So if I'm going to perform the query now, I have to calculate 10 raised to the power. Okay, so I think it is not visible. So what I'm going to do, I'm going to use a power of 10 and something of count digit of right minus count digit of left minus 1. So I can get the number of zeros that should be followed by after 1, so that I can get my desired output. So 12 minus 10 should be 2 here. So yeah, you can see that in this case, wait, yeah. So in this case, I'm going to do 10 power raised to power minus 3 and minus p of 0. So p of 3 is 2 here and p of 0 is 1. So I'm getting 10. So after this, 12 minus 10 will be 2, and my summation was already correct, it is 2, but my number was incorrect, which I have found by the help of this count digit. So now my number will be 2 only. So I got my answer as a 4. So let me tell you how we are going to calculate this. Okay, yeah. So this is the code for finding the prefix vector. So finding this prefix vector, it will take a time complexity of big of n. That is the size of the query, size of the string, and same for vector of non-zero. This will also be calculating the time complexity of big of n. And for the digit count, it is same, it will be calculated in the time complexity of big of n. After finding these three arrays, now we have to perform the query. This is the code of performing the query. This is the code of performing the query. So how it is going to perform the query? First of all, I am just finding the sum and the requirement. First, if I equal to 0, it means that if both index are same, like if I'm finding that 2 and 2, so what does 2 and 2 means? 2 and 2 means that I'm just pointing to that index only, so the summation and the requirement of the number will be the number itself. So if I am just if I'm just pointing to the particular number, then I don't have to do anything. I have just to multiply, I have just to do the square of that number, because suppose I have this number 102031. Okay, I'm just pointing to this number. My left and right is pointing to 1 itself. So my summation will be, what would be my summation? Summation will be 1, and my number will be also 1. So it is basically 1 square. So I'm just going to do a square. So this code will perform the square, and I will continue for the next number. If I equal to 0, I equal to 0, it means that I am using the complete array. If I'm using the complete array, I cannot go to the -1 index. So because in the query part, what we do, we just subtract from the left index, we just subtract the -1 in it. So it is not possible to subtract 0 -1, because it will give you a bound access error. Okay, so I will get n of -1 will give you error. So we are handling this case. This is a special case when the left index will be 0. If left index is going to be 0, our requirement will be only fulfilled by the jth index. And otherwise I'm doing the same. I'm finding my digit count, how many digits should be there. And after finding the digit, I can know the total shift is required by 10 raised to the power p. I've already told you, like what is here p. Here p is representing d of right minus d of left minus 1, and I'm just raising the 10 raised to the power p. So it is a total shift. and just you have to just complete the shifted y, and just you have to subtract the non-zero minus shifted y. And I'm just using a modulus because our number could be very large, so that we are going to use a modulus so that it comes within the integer limit. And after that, this is the condition for finding the summation, that is a prism. Okay, and after that, just multiply the requirement and the summation, and just take the mode of all of these, and just report the answer into the vector. So result, you will get your answer. So obviously all this okay, so this query, the complete query will be performed in the time complexity of big of n. So finally, what is going to be the solution, like what is the total time complexity for this problem? It will be big of 3 times n plus big of q times the number of queries. So the top overall time complexity will be 3n plus q, that is eventually be 4 plus n plus q, and whatever be the larger number here, so it will be the time complexity of big of n. And what is going to be the space complexity? Space complexity is going to be big of 3n, because we are using three vectors here, three different vectors here. One for storing the prefix sum, one for storing the prefix number, and one for storing the count digit, that is going that helps us to calculate the 10 raised to power something. Okay, so that the space complexity will be big of n. So after this, we can find the solution of this problem in the time complexity of big of n and the space complexity of big of n. So let us run this code on the LeetCode. So as you can see, okay, so just I have used an external. I have not used the inbuilt function of the power, because it may give us a different number, because it is not preferable for the large numbers. So for the safe reasons, I am going to use this power function that I have already written in here. And otherwise, all the things that you have seen is just the same. Okay, let me submit the code. As you can see, we have already passed all the test cases. Now let me submit the solution. Yeah, our submission get submitted. Thank you.